Good morning, children. In today's class, we are going to learn the various formula and book back one-word questions in Chapter 10 of 12th Mathematics. Ordinary differential equations. Here, we are having the order and degree questions and then solving differential equations using variable separable method, homogeneous method, linear type. As we go on to linear type, we have two types, linear in Y as well as linear in X. We have more problems using the idea integrating factor, which reads as e power integral p dx. When you have linear type 1, just look out for p and use e power integral p dx. Go on to the last exercise of this chapter. Learn to work out each 1-mark question and understand better. Exercise 10.9. Question number 1. The order and degree of the differential equation. As we read the differential equation, we must ensure that the differential coefficient must be free from the radical symbol. Here, dy by dx is having the power 1 by 3, that is not valid. So take the problematic factor to the other side. So as I rewrite the question, it is d square y by dx square plus x power 1 by 4 is minus dy by dx the whole power 1 by 3. The plus term goes to the right as minus term. The problem is with the degree, the denominator. To get rid of it, raise to the power 3. So raising to the power 3 on both the sides. We get d square y by dx square plus x power 1 by 4 the whole power 3. RHS minus, if I raise to the power 3, it is negative. dy by dx the whole power 1 by 3 we raise to the power 3 minus, when I raise to power 3 it is still negative. dy by dx the whole power 1 by 3 as I raise to the power 3, 3 and 3 will get cancelled. Now there is no radical symbol. Can I have x to be power 1 by 4? Yes, that is allowed. Differential coefficient should not contain fraction power. We have got rid of it. Now, we have to check where the highest order is coming. This is the term. So, d square y by dx square. The order is 2. The whole power 3 tells me this is degree. So, as I read, this I will say order. And this I will say degree. So 2 is the order, 3 is the degree. My question is order and degree. 2, 3. So the right option is A. Question number 2. The differential equation representing the family of curves y equals a cos x plus b, where a and b are the parameters. Whenever I have two constants, I have to differentiate twice. So y becomes dy dx, a as it is, cos when I differentiate minus sine x plus b. X is having no coefficient, so I can just write cos as minus sine. When I differentiate again, it is d square y dx square minus a as it is. Sin x plus b becomes cos x plus b. Minus a as it is. Sin x plus b becomes cos x plus b. Now, wherever a cos x plus b comes, I can put y from equation 1. So, from 1, I can write d square y dx square is minus y. Bringing to the left side, It is d square y dx square plus y equals 0. Out of the 4, we have option B to be the right choice. Question number 3. Order and degree of the differential equation root of sin x into dx plus dy, root of cos x RHS dx minus dy. What is not allowed in this? I need to have dy by dx pattern. So throughout, let me divide by dx. As I divide every term by dx, check out what we get. It is root of sin x into 1 plus dy by dx. It is root of cos x in the RHS, 1 minus dy by dx. Now dy by dx does not have any radical symbol. We can have root sin x, root cos x in the question. Dy by dx should be free from any coefficient. Even if I bring to the left, dy by dx does not get cancelled. So the order we have 1, whole power nothing tells me 1. So the degree is also 1. So the right choice is 1, 1. Option C is the right choice. Question number 4. The order of the differential equation of all circles with center at h, k and radius a. My question is not to find anything else other than order. Order depends on the constants. Here nothing is mentioned as arbitrary or any other constant. So I can treat h, k, a. There are 3 constants. As there are 3 constants, we will differentiate thrice. So 3 constants tell us that we need to differentiate thrice. That is 3 times. So 3 times tells me 3 will be the order. So the question is to find the order. Order is 3. Option B is the right choice. Question number 5. The differential equation of the family of curves y equals a e power x plus b e power minus x, where a and b are the arbitrary constants. 2 constants claim us to differentiate twice. Y becomes dy by dx, a as it is, e power x derivative e power x, plus b as it is, e power minus x is e power minus x, minus x tells me minus symbol. When I differentiate again, it is d square y by dx square, a as it is, e power x is e power x, plus b as it is. There is a minus symbol. E power minus x becomes e power minus x. Because it is minus x, we have one more minus symbol. That becomes a e power x minus into minus plus. So it is plus b e power minus x. And this is nothing but y from the given equation, which we name as 1. So from 1, I can say the given second derivative reduces to y. Bringing y to the left, we have the answer. D square y by dx square minus y equals 0. So the right option is B. Question number 6. The general solution of the differential equation dy by dx is y by x. As I separate the variables, I can rewrite the equation as dy by y equals dx by x. Once we separate, let us integrate. As we integrate, dy by y becomes log y. Dx by x becomes log x. And since these two are in log, constant also let us introduce as log. So since k is given in the question, let me treat the constant as k. As we simplify, it is log y equals log plus symbol claims us to multiply. So it is log kx. As I multiply, when the There is plus symbol. Log, when I raise to e power gets cancelled. So we are just left with y equals kx. Whenever we remove logarithm, we can also forget the modulus symbol. Modulus is introduced only when logarithm, because log of negative values are not defined. So our final answer is y is equal to kx. So option C is the right choice. Question number 7, the solution of the differential equation 2x dy by dx minus y equals 3 represents. Bringing minus y to the other side, it is plus y plus 3. Separating the variables, 2 dy by y plus 3 equals x by dx goes to the right as dx by x. As we separate, let us integrate. 2 into dy by y plus 3 becomes log y plus 3. Dx by x becomes log x, and constant let us introduce as log c. Side number will go to the power. Logarithm rule, side number goes to the power. It is log of y plus 3 the whole square. RHS, there is plus symbol. Logarithm with plus symbol tells us to multiply log of cx. Raising to e power, log gets cancelled. We are left with y plus 3 the whole square is cx. As we remove logarithm, let us remove modulus symbol also. So we get y plus 3 the whole square equal to cx. This reduces to a parabola type where we have y square equals 4ax pattern. So parabola is the right choice. Option C is the correct option. Question number 8. The solution of dy by dx plus px into y equals 0. When we have linear equation dy by dx plus py equals q type, the solution is y e power integral p dx equals integral q e power integral p dx dx plus c. If I compare this format, here q equals 0. If I substitute y e power integral p dx, RHS, this is 0 plus c, it is simply c. Or y equals c, LHS, it is with plus. If it goes to the right, it will go as negative power. C e power minus integral p dx. Out of the 4, we have option B to be the right option. Question number 9, the integrating factor of the differential equation. As we look at the equation, we compare with the general format dy by dx plus py equals q. Q should be a function of x alone. Here y comes in the right, which is wrong. So we take to the left side. As I rewrite the question, it is dy by dx plus y. Y by x I am bringing to the left as minus y by x. RHS, we have only 1 by x. As we take y as common, dy by dx plus y into, it is 1 minus 1 by x. 1 minus 1 by x. RHS, we have only 1 by x. What is integrating factor? E power integral p dx. In this question, p represents 1 minus 1 by x. As I simplify, e power 1 becomes x minus 1 by x becomes log x. As we simplify, it is e power x, e power minus log x. E power x, e power minus log x. If you have minus preceding logarithm, it will be log of reciprocal. E power minus log x. E power minus log x is rewritten as log of 1 by x. E power log cancels. So we are just left with e power x into 1 by x. Out of the 4, we have option B to be the right choice. Question number 10. The integrating factor of the differential equation is x. Integrating factor is x. But we know the formula for integrating factor, e power integral p dx. They have given it to be x. So, e power integral p dx is x. Or, if I take log on both the sides to forget e, log of e power integral p dx is log of x. We know log e will get cancelled. Integral p dx is log x. What does it mean? We know integral 1 by x dx is only log x. So, if I compare, I get p equals 1 by x. Out of the 4, option C is the right choice. Question number 11. The degree of the differential equation y of x is 1 plus dy by dx plus 1 by 1 into 2 dy by dx the whole square plus 1 by 1 into 2 into 3 dy by dx the whole cube. As we see, it looks a very difficult problem, but it is not so. As we recall, e power x is 1 plus x square by 2 factorial, x cube by 3 factorial, and so on. I just compare the RHS with this expansion. Instead of x, we have dy by dx. 2 factorial is 1 into 2, 3 factorial is 1 into 2 into 3. So, we can just write y of x is nothing but e power, instead of x, I have dy by dx. Whenever I don't want e, let me take log on both the sides. So, as I take log, it is log y, that is log e power dy by dx, cancelling log e. We get log y equals dy by dx. It has reduced to a very simple expression. And now, what is the order? Dy by dx tells me order is 1. My question is to find the degree alone. The whole power, nothing tells me 1. So, degree is 1. Option C is the right choice. Question number 12. If P and Q are the order and degree of the differential equation, we need to check some relationship between P and Q. First, let us find out the order and degree of the given differential equation. No differential coefficient is having fraction power. I can directly write the order and degree. Order, as I choose this having the highest order, here order is 2. Degree, the whole power, nothing tells me 1. So the degree is 1. Given P is the order, so 2 is P. And Q is the degree, so 1 is Q. As I look at, P is greater than Q, so option C is the right choice. Question number 13. The solution of the differential equation dy by dx plus 1 by root of 1 minus x square equal to 0 is. As we see the equation, let us bring variables to be separated. Dy by dx is minus 1 by root of 1 minus x square. As I cross multiply, dy by 1 equals minus 1 by root of 1 minus x square dx. As we integrate, dy, the integral is y. 1 by root of 1 minus x square, the integral is sine inverse x. Minus symbol as it is plus c. Bringing minus sine inverse to the left, it is y plus sine inverse x equals c. Option A is the right choice. Question number 14. The solution of the differential equation dy by dx equals 2xy is. As we separate the variables, it is dy by y equals 2x dx. We shall integrate. Dy by y gives us log y. 2 as it is. Integral x becomes x square by 2. Integral x is x square by 2. Dy by y gives us log y plus c. Cancelling 2 and 2. We get log y equals x square plus c. But my options are not having logarithms, so raise it to e power. E power log y equals e power x square plus c. Cancelling e power log, we get y equals e power c is again a constant, so I can just say c e power x square. Out of the 4, option A is the right choice. Question number 15. The general solution of the differential equation log of dy by dx equals x plus y is. When I don't want log, let me raise to e power. E power log gets cancelled. We are just left with dy by dx. E power x plus y tells me e power x into e power y. Separating the variables. E power y I should take to the left, which goes as e power minus y dy. Dx goes to the right as e power x dx. As we integrate e power minus y, when I integrate e power minus y into minus symbol equals e power x becomes e power x plus c. Or if I bring to the same side, it is e power x plus e power minus y equals minus c. Instead of minus c, we can very well say plus c because c is just a constant. We can alter it according to our choice. It is e power x plus e power minus y equals constant. So option B is the right choice. Let us quickly recall the problem. Because I don't want logarithm, I raise to e power. E power log cancels. RHS we have plus symbol in the power. E power x plus y can be split as e power x into e power y. Separating the variables, e power plus y comes to the left as e power minus y. Taking dx to the right. E power minus y as I integrate minus e power minus y. E power x becomes e power x. Bringing them to the same side, taking c to the other side. We have minus c, which can also be treated as a big constant. So option B is the right choice. Question number 16. The solution of dy by dx equals 2 power y minus x. As we split 2 power y into 2 power minus x. Bringing 2 power y to the left, it is 2 power minus y dy. Taking dx to the right, it is 2 power minus x dx. As we have separated the variables, let us integrate. Remember the formula, integral a power x dx is a power x by log a. A power x dx is a power x by log a. Applying that here, it is 2 power minus y by log 2. Because minus y is coming, put minus symbol. Similarly, 2 power minus x becomes 2 power minus x by log 2. Because minus x is coming, put minus symbol plus c. As I bring minus term to the left, it is 2 power minus x by log 2 minus 2 power minus y by log 2 equals c. Cross multiplying by log 2. 2 power minus x can be written as 1 by 2 power x. 2 power minus y can be written as 1 by 2 power y. This log 2, as I cross multiply, it is c log 2. C log 2 can still be written as a big constant. So my option is 1 by 2 power x minus 1 by 2 power y. That is a constant. So option C is. Question number 17. The solution of the differential equation. dy by dx equals y by x plus phi of y by x divided by phi dash of y by x is. As I look at the problem, it looks like homogeneous equation. So let us put y equals vx. As I differentiate, y becomes dy by dx. Vx, keep v, x becomes 1 plus keep x, v becomes dv by dx. As I substitute in the given question, dy by dx is v plus x dv by dx. RHS y by x. If I keep y by x, it will become just v plus phi of y by x will be v, denominator phi dash of v. V and v gets cancelled. As we separate the variables, phi of v by phi dash of v reciprocate. Phi dash of v by phi of v into dv equals x by dx goes as dx by x. As I integrate, phi dash of v by phi of v, derivative in the numerator tells me log of denominator. Denominator, derivative in the numerator. Integral will be log of denominator. RHS, integral dx by x is log x. And because both are in log constant also, let me introduce as k because k comes in the question. We know log of phi of, we have completed the integration. Wherever v comes, I can write y by x. RHS, there is plus symbol in logarithm which claims us to multiply. It is k into x. Raising to e power, log gets cancelled. We are just left with phi of y by x is k into x. Out of all, option B is the right choice. Question number 18. If sin x is the integrating factor of the linear differential equation, we need to find p. We know integrating factor is e power integral p dx. Given e power integral p dx is sin x. Taking log on both the sides, I get integral p dx equals logarithm of sin x. Either we recall integral of cot x is log sin x. So the right option is D. Supposing you do not remember the formula, how are we to get from here? Taking derivative on both the sides. D by dx of integral p dx is d by dx of log sin x. As we differentiate, derivative and integral cancels. We are just left with p. Derivative of log sin x. Logarithm becomes 1 by sin x. We are differentiating. Logarithm becomes 1 by sin x. Hide log. Sin x derivative is cos x. Cos x by sin x is cot x. So either you recall cot x, the integral is log sin x. So direct answer. If not, take differentiation on both the sides and arrive at the right choice. That is D. Question number 19. The number of arbitrary constants in the general solutions of order n and n plus 1. Let us remember, if there are two constants, we differentiate twice and the order is 2. Here, the order is n, tells us there will be n arbitrary constants. When the order is n plus 1, there will be n plus 1 arbitrary constants. So, order and arbitrary constants will be equal. So, order equals number of arbitrary constants. So, if I use this idea, when the order is n and n plus 1, arbitrary constants will also be n and n plus 1, and the right choice is B. So, let us recall a great concept that order of a general solution will be the number of arbitrary constants. Question number 20. The number of arbitrary constants in the particular solution of a differential equation of third order. Whenever we are given particular solution, let us remember the concept. Particular solution does not contain any arbitrary constant. So, particular solution does not contain, remember the idea, does not contain any arbitrary constant. So, the number of arbitrary constants will be 0. Option D is the right choice. Remember the concept, particular solution does not contain any arbitrary constant. Question number 21. Integrating factor of the differential equation. Whenever I want integrating factor, it must be of linear type. Linear type claims us RHS should be fully of x or fully of y. Here it is dy by dx pattern. So naturally RHS should contain only x. This y term I must bring to the left. So rearranging the equation, dy by dx equals, I can combine x plus 1 because I have that in the denominator. X plus 1 divided by x plus 1 plus y by x plus 1. Bringing this y term to the left, it is dy by dx minus y by x plus 1 equals x plus 1 cancels, which is 1. Now my question is integrating factor. So what is integrating factor? The formula e power integral p dx. Here e power integral. What is p actually other than y? The remaining terms. The remaining term is minus 1 by x plus 1. Minus 1 by x plus 1 into dx. So we want to write it in the pattern dy by dx plus py equals q. So other than y, the remaining is p. Other than y, the remaining is minus 1 by x plus 1. As we integrate, minus comes out. 1 by x plus 1 is log of x plus 1. And we know whenever we have minus before log, taking to the power, it is log of reciprocal. Cancelling e and log, we are just left with 1 by x plus 1. My question is the integrating factor, which is 1 by x plus 1, and the right option is A. Question number 22. Population P in any year T is such that rate of increase in the population. As I read rate of increase in the population, it is dP by dt. Rate tells us dP by dt. Proportional to population, that is P. Whenever I see this, I can immediately remember P is equal to C e power kt as our answer. Or let us derive it. dP by dt equals K into P. As we remove the proportionality, we introduce a constant. Separating the variables, it is dp by p equals k into dt. As we integrate on both the sides, it is dp by p, that is log of p, RHS kt plus c, raising to e power, it is e power log p, that is e power kt plus c. E and log gets cancelled, p equals e power c can still be written as a constant into e power kt. Or you remember, whenever you have dp by dt proportional to p, immediately remember the solution, p equals c e power kt. And the right option is A. Question number 23. P is the amount of certain substance left in after time t. Rate of evaporation. As I read out rate, let me remember it is dp by dt. Proportional to. So we put proportionality, amount remaining. What is the amount remaining? P is the amount left. So that is P. Whenever we have proportionality, we can remove using a constant. Because it is an evaporation, I can say minus Kp. Because it is decreasing, I just put minus k, and whenever I say, I remember k is a positive constant. Why do we put minus symbol? It is evaporation. It keeps on decreasing. The next step, dp by p equals minus k dt. As we integrate, I get log p equals minus kt plus c. Raising to the power e, we get p equals c e power minus kt, where k is positive. So out of the 4, option B is the right choice. Question number 24. Solution of the differential equation dy by dx equals ax plus 3 by 2y plus f. Represents a circle, then the value of a. As we separate the variables, it is 2y plus f into dy equals ax plus 3 into dx. As we integrate, 2 into y becomes y square by 2 plus f constant, dy tells me fy. RHS a, x becomes x square by 2 plus 3 is a constant, dx tells me put 3x. And we will introduce a constant. Bringing all the terms to the same side, I get minus ax square by 2 minus 3x plus 2y square by 2 plus fy minus c equals 0. Throughout I multiply by 2. I get minus ax square minus 6x plus 2y square plus 2fy minus 2c equals 0. As we know, circle tells me coefficient of x square must be equal to coefficient of y square. As I compare, minus a must be equal to 2, or we get a equals minus 2. Out of the 4 options, option B is the right choice. Question number 25. The slope at any point of a curve y equals f of x is given by dy by dx equals 3x square, and it passes through minus 1, 1. We need to find the equation of the curve. As we separate the variables, it is dy equals 3x square dx. As we integrate, dy becomes y, right hand side 3, x square becomes x cube by 3 plus c. As we cancel 3 and 3, we get the equation as y is equal to x cube plus c. Given it is passing through minus. What do we mean by passing through minus 1, 1? Wherever x comes, put minus 1. Wherever y comes, put 1. So 1 equals minus 1 the whole cube plus c. 1 equals minus 1 plus c, or c equals 1 plus 1, that is 2. Once I know c value, let me substitute in the equation. So this let me call 1. So equation 1 implies y equals x cube plus 2. So the right option is A.